Welcome to Test Thriller class. In this video, I'm going to talk about number bases, and this video will be the part 1 of the topic number bases. So let's talk about number bases. To understand number bases, you need to understand what is known as a number system. A number system is a counting system such that we define the number of digits in that counting system. So what I mean by that is this. The common counter system we know is a system where we have 0 to 9. So in that system, what we are saying is the maximum number of digits we can have is 10. So if you count 0 to 9, that gives you 10. So that counter system has what is known as a base. So the base is defined as the number of digits that is allowed in that number system. So what then do we mean by number bases? A number base is the number of digits that can be used in a number system. So in the conventional number system, that is the one we all know about, we know we have 0, we have 1, we have 2, we have 3, we have 4, we have 5, 6, 7, 8, 9. If you count, you will notice that we have 10 digits altogether. So in this number system, the base is 10. So we call this system a decimal system. But then we have other kinds of number system. We have other type of number bases. Aside the decimal system, there are other types. If you have a system with two bases, you call that binary system. So in this case, the allowed digits will be, as you can guess, 1 and 2. 1 and 0, that's 0 and 1. So what this means is, in a binary system, you can only make use of 0 and 1 as your digits. The other ones, we have base 3. In the case of base 3, in a base 3 system, you can only use 0, 1, and 2. In a base 4 system, you can make use of digits 0, 1, 2, and 3, and the list goes on. We also have number systems that are above 10. So we have, for example, we have base 16. Base 16 system. This one is also known as hexadecimal system. In this case, we have 0 to 9. Then we have A, B, C, D, E, and F. So where A represents 10, B represents 11, C 12, D 13, 14, and 15. So what you should have noticed is this. For a given base, you can't have that base as part of the digit. So what that means is, if I'm dealing with base 7, I can't have 7 as part of my digit. So the highest digit that I can make use of will be 7 minus 1, which is 6. So I can make use of 0 up to 6. So that's what number basis is all about. So the next thing I'm going to talk about is, how do we add numbers in different number system, in different number system with different bases. We are very conversant with that of decimal system. That's all we've been taught for the most part, right from nursery school. But in this particular video, I'm going to explain or explore other number systems, and you'll get to see how interesting they are. So let me first talk about the way we perform arithmetic operation on decimal system. So let's say you want to add in a decimal system. So let's say you have 25 and you have 28. To add in this case, what do? you take 5 plus 8. That will give you 13. Now, when you have 13, what do? Since you are dealing with a base 10 system, it means you have to take out multiples of 10 out of 13. And that's the reason why we normally write 3, then we say we carry 1. So that one we are carrying is not actually 1, it's actually 10 in the real sense, because what you've just done is you've isolated 13 into this. Then you've transferred this 10 to this 2, which is like 20, right? So which makes it 3, which is like 30. So here you have 3, you've carried 1, right? And that makes it 3. Then the 3 added to this 2, that gives you 5. And that's the reason why we have 53. The reason why we carry that 1 is because it is in base 10, and that 1 is like a multiple of 10. So in this particular case, it is 10 basically that we are carrying. Okay, what about when we subtract? If you have 54 minus 48, now what happens here when you subtract in base 10, right? So we are dealing with base 10, base 10. Now, when you say 4 minus 8, you know you can't subtract 8 from 4. So what we typically do, we say you borrow 1. But technically, you are not borrowing 1, you are borrowing 10 because you are dealing with base 10. So when you take 1 from this, so you have reduced this by 10. So this remains 4. And if you add 10 to this 4, that will give you 14. So technically, what you are doing is adding 10 to 4 because you are dealing with base 10. And now we have 14. 14 minus 8 will give you what? 6. Then here you have 4. 4 minus 4, this gives you 0. So the answer here is 6. So this is the decimal system. Now, what about performing this kind of operation in base 2, in base 3, and in base 4, and so on and so forth? So that's the next thing we're going to talk about now. How do we add and subtract numbers in different number systems? So let's talk about that. Now that I've demonstrated how to add and subtract numbers in a decimal system, how do we do that in a binary system? Don't forget that binary system means a system where the base is 2. So let's take a look at this example. So let's say we have 1, 0, 1, 1, and we want to add 1, 0, 1. In this case, we want to add, right? In this case, how do we go about it? Now, we just take this one and we add it to this one. Mind you, this is in base 2 and this in base 2. So 1 plus 1 will give us 2. Now, since we're in a base 2 system, you can't write 2. The highest digit you can have is 1. So what do? We take out multiples of 2 from that 2. So 1 plus 1 is 2. So if you take away 2 from this 2, you'll be left with what? 0. So, but in this case, you've taken just 1. How many 2 have you taken from this 2? You've taken 1 2. So that 1 2 will be carried over to this. So it's more or less like saying how many 2 can you take out of 2? We can only take out 1. So that 1 that you've taken out is what you write here. It's the same thing as in base 10. You know, in base 10, if you add up 2 things and you got, let's say, 17. So what you do basically in that case is you carry this one. But what you've done basically is you've asked yourself how many 10 can you get from 17, which is just 1 10, and the remainder is 7. So in this case, since we are dealing with base 2, you will say how many 2 can we take out of this? And now you can only take out one of it, and the remainder in this case will be 0. So 1 plus 1 plus 0 will give us 2. Now, how many 2 can you take out of 2? You can only take out 1 2 out of 2. And when you take out that 1 2, the remainder will be 0. Now, 1 plus 0 plus 1, that will give you 2. How many 2 can you take out of 2? 2? That will give you 1. And the remainder is 0. So in this case, 1 plus 1 will give you 2. Then how many 2 can you take out of 2? That's 1, and the remainder is 0. So this is all we have left. Then you take it down. And here you have the answer in base 2. So let's look at another example. So let's say I have something like this. I have a 2, 3, 1, 2, and this is in base 5. So let's say we have another number like this. So we have 2, 1, 4, 3. Then we have 3, 4, 1, 2, and they are all in base 5. So let's add all of this. So you take 2 plus 3, that will give you 5. 5 plus 2, that will give you 7. So how many 5? So you have 7, right? How many 5 can you remove from 7? We can only remove one 5. If you remove that one 5, you'll be left with what? 2. So this 2 becomes the remainder that you are going to write here. Then this one is what you carry to this. So you carry the 1 to this place. So now you have 1 plus 1, that gives you 2, plus 4, that gives you 6, plus 1, that gives you 7. So you have 7 again. How many 5 can you take out of 7? Just 1. And when you take out that 5, you'll be left with 2. So you have 2, you carry this 1 here. Now you have 1 plus 3, that gives you 4, plus 1, that gives you 5, then plus 4, that gives you 9. If you ask yourself how many 5 can you take out of 9, you can just take out one 5 out of 9. And when you take out that one 5, then you'll be left with what? 4, because if you remove 5 from 9, you'll be left with 4. So you write out what you'll be left with, then you carry the 1 to this side. And now you'll do the same thing here. 1 plus 2, that will give you 3, plus 2, that will give you 5, plus 3, that will give you 8. So how many 5 can you take out of 8? Just 1. And when you take out that 5, you'll be left with 3. So you write the remainder and you take the 1 here. Now that you've got nothing left, you just take down this one, and that will give you the answer in base 5. So this is how you add numbers in different bases. So you can apply the same concept for base 7, for base 6, and so on and so forth. Now let's take subtraction example. So let's say I have this. So I have 1, 0, 1, 1, 0, 0. And now I want to subtract 1, 1, 1, 1, 0, for instance. And this is in base 2, and this in base 2, right? So how do I go about solving this? Okay, the same principle applies. You try to subtract first. 0 minus 0, that gives you 0, so there's no big deal here. Now, 0 minus 1, that's where we have a problem. You can't subtract 1 from 0. So what we typically do is to borrow from the nearest neighbor from 1 here. But in the case of base 2, anytime you borrow the base. So if you borrow 1 from this, what you're going to add to this is 2, not 10, as in the case of decimal system. So if I borrow 1 from this will be there will be 0 left here. Now that 1, you won't add the 1 here because we are dealing with base 2. In base 2, you are not adding 1 because you're adding 1 in the case of base 10 because it's 10. You know, when you add 10 to 0, you give it 10. But in this case, that 1 you borrowed is 2. So 2 plus 0, that will give you 2. Now we can subtract. 2 minus 1, that will give you 1. Now let's move to the next. 0 minus 1, that's not feasible. So we borrow from the nearest neighbor. So when we take 1 out of this, that 1 in a binary system will be 2 when you add it to this one. So if you add this to this one we borrowed, it has a weight of 2. You understand? So this 2 plus 0, that will give you 2. Then if you subtract 1 from 2, that will give you 1. So here you have 0 as well, right? So here you have 0 and 0 minus 1, that's not feasible, right? So you borrow from the nearest. But unfortunately, the nearest is 0. So we move to the next, which happens to be 1. So this one, you take out the 1 here. You borrow this one, you take this one. But when you transfer it to this, the weight of that one you've taken from it will be 2. The weight will be equivalent to the base. So 2 plus 0 will give you 2. Now we can now borrow from this, because now this is now 2, it's no longer 0. We've borrowed from here, we've transferred it here, then this can now borrow to this can now borrow this particular one. So if you take 1 out of this, you'll be left with 1, right? But that one you are transferring to this, we have a weight of 2. So 2 plus 0 will give you 2. Now we can subtract 2 minus 1 will give you 1. Don't forget this is what 1 remaining here. So 1 minus 1 will give you 0, and this is 0 remaining. So the answer is this, in base 2. You can simplify further as follows: 1 1 1 0 to base 2. Okay, so this is how you subtract in a different base other than base 10. So I'm going to take some examples from past questions. That is, I'm going to take some examples from UTME past question, and I'll show you how they've asked this kind of question in UTM. So let's take a look. The next example I'm about to solve is from UTME past question, and you can use test driller UTME to practice and also extract questions that you want to practice. So I'm going to show you how you can use test driller to extract questions that you want to practice based on a particular topic or concept. So I'm going to go to question search. Then under question search, I'm going to select mathematics, and okay, I want to search question everywhere. So what question do I want to search? I want to search any question related to number basis. So what I'm going to do is type number basis, and it's going to give me a question related to number basis. So you can check them out. So these are questions related to number basis. But I'm going to go to a particular year that is relevant to addition and subtraction. So I'm going to go to year 2009. Year 2009. Question number 1. Okay, so this is the question I'm interested in. So the question is that we should subtract 16418 in base 9. We should subtract that from 18630 in base 9. So that's what the question says. So I'm going to show you how to do that now. So the question says if you subtract from we should subtract from this. That is, we subtract 16418, which is in base 9. Subtract that from 18630, which is also in base 9. Okay, let's just apply what we just discussed. 0 minus 8, that is not feasible. So what do? You borrow from the neighbor, from the next neighbor. So if you borrow 1 from this, of course, you'll be left with 2. But in a base 10 system, that 1 is going to have a weight of 9. So basically what you are saying is you are taking that 1 times 9, and that's why it has a weight of 9. So that 9 will be added to this 0, and that will give you 9. So 8 minus 9 minus 8 will give you 1. Then in this case, you have 2 minus 1. That will give you 1. And the next is 6 minus 4. That will give you 2. Then you have 8 minus 6. That will give you 2. And 1 minus 1 gives you 0. So you can ignore the 0 or you just leave it this way. And now you have your answer in base 9. So this is the answer. So let's check what the correct option is. So you can see that the correct option is option D, which is 2211 in base 9. Okay, so let's move on to the next question. The next question will be taken from UTME past question 2004, question 39. 2004, question 39. And that's the last question here. So let's take a look at it. So in this case, the question states that we should look for the value of x and y respectively, and that the base is base 5. So here you have 4, 2, 4, 3 minus 1, 3, x4, and they are all in base 5. And we've been given the answer. So the question is more or less like, what should be the value of x and y that will make that subtraction a valid subtraction? And so we are to get the value of x and y such that when we perform this operation in base 5, everything aligns, or we get a valid answer. So let's take a look at how we're going to approach this, and let's solve it. So let's take a look. Now let's solve the question. So here we have 4, 2, 4, 3 in base 5 minus 1, 3, x4 in base 5, and the answer is 4, 4, 3, y in base 5. So let's analyze it this way. So what we need to do is this. Let's try to perform this subtraction and then figure out how to get the x and y. So what's 3 minus 4? We know that's not possible. So we need to, it's not feasible. So we need to borrow 1 from the neighbor. So if you borrow 1 from this will give you, this will be, you'll be left with what, 3 here. And that's 1 you borrowed. We have a weight of 5. That's like 1 times 5. So that will have a weight of 5. So you add the 5 to this 3. That will give you 8, right? Now, 8 minus 4. That will give you 4. So that's the reason why we have 4 here. Because you see, it lines up. This is correct. Now, here you have 3 minus x equals 4. So the question here is, what should be the value of x? So look at it this way. 3 in base 5, right? Minus x in base. Just think about it in base 5 equals 4. So the question is more or less like, what should be the value of x that should give you 4? Now, the issue here is, since this 4 is greater than 3, it means we must have borrowed 1. Because if, for example, this value happens to be 2, for instance, then it's reasonable to say x is 1, right? That will give you 2, right? If this answer is less than or equal to this 3, then we can easily figure this out. But if this result on the right hand side is greater than the first number here, what it implies is that we must have borrowed something to add to it. So that is what it implies. So, and if you borrow something, if you borrow 1 from the neighbor and you add to this 3, then that means you would have gotten 8, because if you have 3 originally and you borrow 1 from this 2 to add to this one will be 1. The one you borrowed will have a weight of 5 since we're in a base 5 system. So 5 plus 3 will give you what? 8. So this 8 would have been what x would have been what we must have subtracted x from, or what would have subtracted yeah, x from. So in this case, instead of 3 now, we must have borrowed 1, which must have been 5. Then that would have given us 8. So 8 minus x equals 4. That is what you should be working with here. And from this simple expression or equation, we can easily tell that x is 4. If you just make x the subject, you will get something like this, and that means x is 4, basically. So it means x must be 4 for us to get 4 here. And it also implies that we must have borrowed 1 here. So it means we can clearly say that x is 4 based on this explanation. Now that we know x is 4, so next is to continue this. So in this case, we just say 1 minus 3. We know it's not feasible, we have to borrow from here. So if you borrow from here, this will be, you'll be left with 3 on this side. And that one you borrowed, we have a weight of 5. So 5 plus 1, that will give you 6. So 6 minus 3, that will give you 3. So that's the reason why there is 3, which is correct. Now here you have 3, right? 3 minus 1, that will give you 2. So this y definitely must be 2. So it means the original equation is therefore 4, 2, 4, 3 in base 5 minus 1, 3, 4, 4 in base 5, which will give 2, 3, 4, 4 in base 5. So we can say x is 4 and y is 2. So let's check what the answer is. So clearly we can say option B is the right answer, since x is 4 and y is 2. So this brings us to the end of part 1. So watch out for the part 2 of this number based topic.